We're studying IGCSE physics and we're starting thermal physics 5, in which we're going to learn about thermal radiation. Let's just look at a recap of what we've done so far. Recap, we've looked at transfer of heat. Well, we're doing transfer of heat still. This is called transfer of heat. The title today is about transfer of heat in thermophysics. But so far, we've already done conduction, we have done convection, and now radiation. Now, conduction was in solids. Write all of this down. Convection was in liquids and gases. And radiation occurs in, let's say, we'll look at that in a second, what radiation means. Now, quickly write all of this, quick. Radiation occurs in vacuum. Or any medium. Write these part down, the transfer of heat. Even though you may not have done this in class with me so far, you must have a clue of this from your school classes, I think. If still not, I'll tell you afterwards. We'll go over it. Now today in thermal transfer of heat, we're looking at radiation. Let's see what radiation is. Have you finished writing all of this? Lula and Diana and Safa, Zahra?
Yes, sir. And the radiation is that.
Okay. Thermal radiation is basically radiation is when, let's see, from the book. Diana, start reading from here. Objectives.
From where?
Objectives, right here, top.
Objectives. To know which surfaces are the best emitters and best absorbers. To explain what happens when incoming and outgoing energy transfers aren't equal.
All right. Now what we're realizing here is there's some things called emitters and some things called absorbers. Now what are these things? We'll look at that in a second. I'm going to make you write a few things, the key points, and first write all of that, then we'll look at the book after again. So what is radiation? The definition. The definition of radiation is flow of heat from one place to another by means of electromagnetic waves in a vacuum or through a vacuum. Do not require a medium. Does not require a medium. It's for a proper grammar. Now, Safa, read this out loud.
Radiation, flow of heat from one place to another by means of electromagnetic waves through a vacuum, does not require a medium.
All right. Now, Zahra, can you tell me what is the meaning of flow? Let's say, what do you understand from all of this part? Say it in your own words.
A flow of heat from one place to another. But I didn't get the electromagnetic waves.
You didn't get the electromagnetic waves. Electromagnetic wave is like, let's say, like light. Okay, like light. Now I'll show you what it means. I'll just show you. First, write this in your notebook. I'll tell you what these are. Electromagnetic waves are. This one is basically infrared. Infrared waves. Now this is from chapter number 7. Chapter after this. Okay, we don't have to know what it is right now, but you need to know how it happens. It happens because of these things, which are Electromagnetic waves. In brackets over here, right? Infrared. Now tell me when you're done writing. Now, okay, tell me while you're writing, whom of you has done a barbecue at their home or somewhere? Have any of you done a barbecue? I'll show you what it means. When you have a let's say chicken or something, and you cook it on coal like this. Have you done it?
Yes.
I'll show you what it means. Barbecue. Now you must realize I'm just trying to make sense. Whereas this is what barbecue means. Now we did it in our first Farasan. I and my friends went to Farasan and we did all of this barbecue. When you have let's say some anything and you cook it on coal. But one thing is, we realized, look, are these things touching the coal beneath it? Are they touching? Yes, no. Is there a gap between them? Let's say
Yes, sir.
there is a gap. So is chicken touching coal? Now this is not a cooking class, but we need to understand what's happening. So touching coal, no, it's not touching. No. So then if it's not touching, then how does the chicken heat up? How does it heat up? So how does it heat up? You don't have to write this. How does it heat up? Can someone tell me how does it heat up then?
The heat
Lula,
releases
tell them.
out.
Heat releases out. Okay. Lula, what do you think? How does the chicken heat up if it's not touching the coal? Any explanations? Any reasons? Now science is all about thinking. Since I'm teaching you, we have to slow down sometimes. Yeah. Tell me.
I think it's because of there's a flow of heat, like radiation.
Flow of heat. Okay. Okay. Fine. You think because of flow of heat. Zahra said because of release of heat, and you said flow of heat, which is exactly the same. And but what is this flow of heat called, or release of heat called? This is called radiation. Not any type of radiation, thermal radiation. Thermal radiation. Is that clear, Zafar?
Yes, sir.
Right. Now I think that should make it clear. Now, okay, we can see the heat also coming from here. If you keep your hand on top of it will heat up. That is what radiation is. Now let's see which things are good radiators, which things are good at giving or flowing heat or releasing heat. Okay, let's see that. Now, okay. What is an emitter? What is emitter and what is absorber? Let's see. The emitter is basically an object that releases heat, cools down quickly. Write this in your notebook. Now, and that's just a second. No, this part. So the definition is emitter object that, let's say, releases heat. Okay, and all you need to know is also cools down quicker. What is an absorber? Absorber is an object that, let's say, absorber is the object that, let's say, takes in heat. Also heats up quicker. Any questions? Now, Lula, read this from the beginning out loud while writing it.
Emitter, object that releases heat, also cools down quicker. Absorber, object that takes in heat, also heats up quicker.
All right. Now, this one. Object, what is a reflector then? Object that doesn't take in heat, doesn't give out heat, it reflects heat. Okay. Also, heats up slower. We have three kinds of things happening here. Three types of objects. Right? These are the types of objects. Or let's say, let's write over here, types of radiator. Types of objects. Now, emitter, absorber, reflector. Let's first write this down quickly. Tell me when you're done. Each of these are for 2 marks in the exam. Also, we need to see is what we need to realize is reflector also heats up slower, object reflects heat. So bad absorber.
Done, sir.
Okay, Diana, Lula. Now, one more thing. Let's say factors, two factors affecting radiation. Okay. Now, one thing here, I could have said factors affecting radiation. What do you think is the correct word? Someone tell me which is the correct word. Factors affecting radiation or affecting radiation? Is this better? Is this correct? That's not related to physics, but quickly tell me.
Factors. Because
Affecting. This is the wrong word. Okay, it's always affecting. Let's remove that. That's English, but you should, since I'm writing it, I'm also your English teacher, you should understand. Now, affecting radiation. Next thing. And now I have to understand over here is the factors. First factor is color. Color. Second thing is, let's say, what else do we have? We have color and we have surface area. These two things. Now let's see how color and surface area affects things. Okay, I'm going to make a table for you. You have to make the same table in your notebook. Let's make it like this. Fine. Now over here we have two things like this. That's it. The first color is called matte black. And over here color, there are two things also matter, not just color and let's say shiny, shininess, how shiny it is. Okay, I hope there's a better word for it. We'll talk about that later. But you understand what shininess means, right? How shiny it is. Now, okay, matte is, we have matte black, we have white, and we have silver. These are the three kinds of colors you'll be asked in exam. Now finish writing quickly. Let's look at this. You have emitter, the three kinds of objects here: emitter, absorber, and finally reflector. So okay, emitter is, let's see. emitter, matte black is a good emitter. Let's say best. Okay. Okay. Worst. Okay. Next thing is, let's say, absorber. This is the worst absorber. Reflector. This, sorry. This is the worst reflector. This is the best absorber. I hope this should be done. Write this and tell me when you're done.
Done, sir.
Can you see the book on the screen? Or the whiteboard?
Yes, sir.
Now that's what you have to memorize. These are, let's say, good, good, good. But the main question is about black and silver. Now let's see. Add one more thing. No, that's it. That's it. Now let's look at experiments. Experiment 1. First experiment is this one. Look at the book. And I want you to start reading from here. This one. Just a second. So fine. I think I did tell you about this. We have color and reflectiveness / shininess. Okay, matte black is not shining. Matte means, what is the meaning of matte? Matte means not shining.
Not shiny.
That's it. Now the next thing we have to look at is an experiment. The experiment we're doing is, just a second. We'll take a shape like this, a box like this. And all our job is to compare which sides of these has the best emitter, or let's say emitter. Okay, in the exam they'll ask you. So right over here, comparing emitter. Now, how do we solve this one? Well, the first thing we look at is we have a few apparatus here. Write the apparatus.
Sir,
Now this is paper 6. Yes,
are you showing the white screen, like what board right now?
whiteboard. Yes.
Yeah,
Can you
it
see it
wasn't
now?
showing. Okay, yeah.
Fine. Now look at the whiteboard. You have experiment 1, comparing emitters. For this experiment, you need apparatus. Now this this is related to chapter paper 6 practicals, but since it is related to this chapter, we'll do it right now. And now I want you to read. I want you to write this down. First thing first is you need thermal, radiation detector. We need a metal cube with sides of different colors. And that's it. Those are the 2 things we need. We also need boiling water. The next thing is, let's try it with, let's see if I try with metal cubes with different sides of different colors. Let's try this one, black. Now all these sides are black, let's see. Okay, and it's completely black. Our job is to check if I put some water over here. Let's say if I put some water from the top right here, I'm going to fill it up with a lot of water. That's hot water. And then what this thing is going to do, it's going to release some heat around the surrounding, right? That's what happens. All around it, it's going to release some heat. And our job is to see how much heat is it releasing. What we'll do is we'll take a heat detector like this, and it has a meter, some sort of meter, let's say some meter like this. It will give us a reading. Fine. In the exam, you have to draw these diagrams. So draw them right now. You don't have to draw the heat. All you have to do is draw the cube, the circle on top, and all you have to do is make the reader right here. Now, what we realize is, let's say, if let's say one side is black, and if I color the other side as some other color, let's say I make it silver, okay, not black, and this one is completely black. Now let's see what happens. And if I say that is, let's say this is white, okay, and this is black, I'm going to put this radiation detector. Let's say it's giving me a reading 50 right here. Okay, I'll put it at both sides. First, I'll do it on the first side, and then I'll do it on the white side. Now, what we realize is the white side will give very less heat compared to the black side. Okay, the white side will give us less heat. Therefore, we realize observation. Black side is better, let's say, better emitter than white side. More heat is detected on black side. Any questions? Now please read Lula, read the apparatus out loud.
Number one, thermal radiation detector. 2, metal cubes with sides of different color. 3, boiling water.
Diana, read the observation.
Observation. Black side is better emitter than white side. More heat is detected on black side.
So what we realize is since more heat is detected on the black side, that is why it is a better emitter. Let's make this point actually the second point. Now tell me how much I have all of you written. You know,
So
observation. So black side is better emitter than white side. Next experiment is basically comparing absorbers. Look, I'm spending more time on this because I want you to understand. I don't care about, let's say, running off completely. If you understand and if you have all the details, you can answer all questions in the exam. Experiment 2. The apparatus in this case are going to be, you have basically, let's say, you have a thermometer. You have metal plates. Different color. And you need a heater. Not boiling water, but a heater. And what would this experiment look like? This is what it would look like. You have 2 metal plates, let's say one like this, and another metal plate like right here, another one right here. And in between these, I'm going to put a heater. let's say some heater, which is going to release heat both these sides. Let's call this the heater. So make the diagram. Diana, are you done with the first experiment? This side, I'm going to make it completely black. And this side, I'm going to make it, let's say, white. If I can show you a better color for white. Let's say this is white. We have black and we have white. Now, which is a better, let's say, absorber, black or white? This is black and this is white. All we realize here is the apparatus. We have these apparatus. We're using a thermometer. Instead of this detector here, what we're going to do is we're going to place a thermometer in these places. Let's say a thermometer like this. And if I place this right here, it will detect how much temperature does this side have or does this side have. Now quickly, tell me, Lula, have you finished writing this part? Zahra, let's move on to this now. So we have a thermometer here. What it's doing actually is, once the heater is going to heat both the sides, but what we realize that one side is not a good absorber. Whichever is a better absorber will get more heat, will increase in the temperature more, right? If this guy absorbs more heat, it will have a higher temperature. Now let's see which one is absorbing the higher temperature. Diana, tell me which is better absorber, black or white? Better absorber between black and white. Waiting.
So you asked me or Diana because our name pronounced like exactly same.
Diana.
The way you
Right?
call us.
Okay. Okay, all right. Diana, can you hear me?
Yes, sir.
Tell me which is a better absorber, black or white?
It's black.
Black since it's best, so that's just good. Okay,
Yeah.
let's see. So observation will be black side is better absorber than white side. Black side rises to more, let's say, to higher temperature. So absorbs more heat. Let's take this part below here. This is part 2, step 2. 1. Any questions? Tell me.
Yes, sir.
Next thing is that's about it in this. Now we have the final thing, which is called thermal capacity and latent heat. After this, we're doing thermal capacity, latent heat. Write this quickly. Tell me when you're done. Equations or formula you need to memorize in this. It's going to be these two. First one is E is equals to mc delta T. The second one is E is equals to ml.
It's done, sir.
Done. Safa,
Done, sir.
There's no rush. Take your time, write properly. If you want, I'll send. You'll get the notes, right? Also, but if you don't, if you're not able to write, tell me and I'll show it to you again. I'm going to move on to thermal capacity and latent heat. Now write these formulas in your notebook. E equals mc delta T and equals mL. Now this L could be of two types. F stands for fusion, or it could have been for vaporization. All right, guys, finish writing this. How much have you finished?
Sure, the left.
Say that again.
Formula is left.
Formula is left. Write that, just that. Now, since you're writing all of this, if you can just memorize your notebook or go through it, revise it every time, you'll have all the chapters with you. So after this, I don't think you'll ever have to, let's say, you won't forget this because you have all of this written down. All you have to do is read it again and watch the class recording. Now, my way of teaching is that you don't have to come back to any chapter any after this. We do it once, then done, never come back, unless afterwards to revise, right, or to solve questions. Safa done writing? I'll tell
Yes,
you
sir.
what latent heat means. Now, okay, this right here is specific heat capacity. The C stands for specific heat capacity. And the L over here means latent heat. What is the meaning of this? Latent heat and specific heat capacity. Do you guys know? Can you tell me? Ara, can you tell me what specific heat capacity is? Yeah, you must have done this in school. Now,
Can you repeat your question?
the question is, what is specific heat capacity?
Let's say it.
Say that again.
Less heat.
No,
Specific
not
heat.
really. No, no, not that. Safa, do you know what specific heat capacity is?
No, sir.
No. All right, Lula. Then I'll tell you. Write this in your notebook.
Isn't it like energy required?
Energy required, yes. So,
To
so
increase.
this is the right. Energy, amount of energy required to raise the temperature of 1 kg of certain substance by 1 degree Celsius, by 1 C. Now this in the exam is going to be 2 marks. So if you can just memorize this, 3 marks, right? Well, definitions you have to memorize, but the questions you have to solve with me. Quickly write this so we can start doing questions. The problem is that I will do questions, but before I do questions, I have to teach you things. Otherwise, you won't understand the questions. Now write this quickly, tell me when you're done. And what is latent heat? Latent heat is, I'll tell you. A fusion or vaporization. There are two types. Energy required to melt / boil. Now you need to realize over here what's happening is the fusion, this one, fusion goes with melt, and the other one, vaporization, goes with boil. These are actually two formulas. I'll actually write it differently for you, never mind. First, finish writing the first one. And latent heat of fusion is this. And latent heat of vaporization is exactly the same. Boil. Now write it. Tell me when you're done. Now, after this, when I ask you what is specific heat capacity, you should know that it is the amount of energy you have to put into something or anything. Let's say your water, let's say metals, let's say anything. If you're putting that amount of heat there, it will increase the temperature by exactly 1 degrees. Specific heat capacity is the amount of heat you have to put in to increase the temperature by 1 degree of 1 kilogram of that substance. So example of this would be, if I have in this beaker, let's say 1 kilogram of water. Now I'm heating this from the bottom, and the temperature, let's say, was 10 degrees. Let's say it was 12 degrees Celsius. And then after heating it, it became 13 degrees Celsius. Now this increase in 1 degree of 1 kilogram of water, this is 1 kg, is called latent heat. This is called specific heat. Any questions? Safa?
Sir, can you explain it again?
I'll do it one more time. Now if I have 1 kilo, how much water do I have? 1 kilogram. How much?
1 kilogram.
Now louder. Someone else say it louder. How much do I have? Water.
1 kilogram.
1 kilogram. All right. Now how much will it cost you to get 1 kilogram of water? Let's say if you want to buy it, let's say 1 kilogram is like 1 liter. Now if you buy 1 liter of water in Jazan, how much will it cost you? Let's say in Rashid Mall or Hyper Panda. Give me any price. Quick.
10 riyal.
10 real, that's too much. 1 liter, that's actually no more than one real is for, let's say this is going to be, just to be on the safe side, I'll say 5 real. I don't think it will be 5 real, perhaps 1 real, but let's say 5 real. Okay. Now to get this water, you have to pay 5 real. But what do you have to pay for it to go from 12 degrees Celsius to 13 degrees Celsius? What do you have to pay? That's the question. And I have to pay not in real. Water does not care about real. Nobody in nature, we don't care about money. Money is it's something we made up. But to go from 12 degrees to 13 degrees, how much do I have to pay? I have to pay, let's say, 500 joules of energy. Joules of energy. Now this amount of energy I have to put is called the specific heat capacity. Is that clear?
Yes, sir.
To go from 12 degree to 13 degree, I have to heat some amount of energy. This heat is the amount of energy I have. This heat over here, and that is called the specific heat capacity. Are any questions? Diana, Lula?
No, sir.
Fine. And in the same way, now let's look at fusion. I have a solid cube like this, or just give me a second. Now, whoever has their mics off are going out of class. I need mics on, all of you, quick. Because there's no reason to turn off your mic. Quick, on. Turn it on. Zahara, Lula.
presents here have my fourth third.
It's all right. No, let's just let the background noise be there, right? You can't remove it, and that's all totally all right. The problem here is you have an equation on the screen, and what is the answer? I need one of you to work with me.
Okay, is the answer 907.49?
907.49. Now, Zahara, why could you not find the answer?
Sir, see, I don't have the calculator right now. So I was just trying to work out on the.
All right. So C is 907.5, and the units, you need the units as well. Units are important. Without them, you're not getting marks. Units. So the answer for this is joule per kilogram per degree Celsius.
My answer is correct.
Your answer is correct, yes. Now, Safa, work with me. Why was your answer wrong?
So I just put the number at the place of C and I just like multiply it all one minus.
Okay, so 14.1.3. Now, guys, do you know how to solve using the equation solver in the calculator?
No.
All you have to do is put the numbers here and place of what you're trying to find, put x. And then when you solve it, your calculator will give you the answer, 907.49 or 907.5. That's the answer.
I didn't do that. What I did was I subtracted 41.3 from 13.1, and then I multiplied it with 0.93, and then the total I divided it from 22,380.
Right, that's perfect. But in the exam, you'll not have so much time, especially in MCQ. You have 1 minute for one question. So you have to use, or let's say you'll have to use some tricks or some methods to get the answer quicker. Fine. So I want you to do it that way, which you did right now. Forget the other methods, but when the exams are closer, I'll teach you a lot of methods to save time in the exam. Now, I am, as a teacher, I specialize in getting A stars in your exams, right? So I'll tell you how to do that after you finish learning with everything. That would be later, perhaps next month or after that. Now, again, specific heat capacity, we know that, so that we can solve that. Zahara, can you tell me what is specific heat capacity?
What is the heat capacity?
Yes.
Answer. I don't know.
Say that again, louder.
It's the heat defined by the amount of heat. We can like
Read the definition in your notebook.
so I haven't written the definition of this.
Why not? Then I asked you if you have written it or not. Otherwise, how will you solve the question in the exam then? You're telling me that you guys have written. Who has not written the definition of which I gave you? Diana, Lula, Safa, have you written the definitions I gave you?
Yes,
Yes,
sir.
sir. Yes, sir.
Now, I need you to be honest with me. If you've written, if you don't have time, or if you have something more important, perhaps.
Sir, I have written, sorry. It's
Written
specific
this?
heat capacity amount of energy required to raise the temperature of 1 kg of a certain substance by 1 Celsius.
1 degree Celsius, yes. But exactly that you just have to write here. I don't think this should be difficult. Yes, any questions?
No, sir.
Now let's next one. Solve this question on your own and write the answer in the chat separately. Send it on WhatsApp. Do it in your notebook. This is the last thing we're doing. Second question.
First and second.
Yes, first and second. The first of the first one. Send me a picture on WhatsApp. Diana, Luna, Safa also start doing. Now for a question like this, you're not getting any more than, I'll tell you the time. The amount of time you're getting for this is going to be a minimum of 2 minutes. It's a 2-mark question. So the timer starts now. Progress. Safa, how much have you finished?
Sir, I want to ask something.
Ask
In
me.
the formula, the,
Yeah. The formula.
there's a triangle T, right? So what does that
Yes.
mean?
This means delta. The triangle here means delta. What is it called?
Delta.
Delta, not tra. Ta. Delta means change. Okay, change. So change in temperature. This whole thing is going to mean change in temperature. So how much is the temperature changing? First, you'll have to look at the initial temperature and you'll have to look at the final temperature. Or if you don't have initial final, you have to see how much is the temperature increasing or decreasing. So change in temperature. That is what delta T means. In the question, they have told you that the temperature is increasing by 12. So it's changing or increasing by 12. How much is it increasing or decreasing? So it's increasing by 12. So that's what you write here.
Sir, and C
Any
means
questions? C means specific heat capacity. Any questions? Anything else?
no,
M
sir.
is the mass and E is the energy supplied. Now all of you can write the if you don't know, then you can write it the arrows, the name of each symbol on your notebook as well. E is energy supplied. Specific heat capacity for the C for capacity ka is C. Delta T means delta means change, so delta is change in temperature. M is for mass. Diana, do you want to do the question with me on the board?
Sure, sir.
All right. Then we have the equation given over here. Let's use that equation again, but we'll write it separately somewhere else. The question is also given. Now read the question. You have read the question, I think. Have you? Read the question.
The mass of the cylinder is 800 grams. The heater delivers 8,700 joules of thermal energy to the cylinder, and the temperature of the cylinder increases by 12 degrees Celsius. calculate
So
a value
what have
for
been,
the
yeah,
specific heat
calculate the value,
capacity.
specific heat capacity. Now tell me the formula.
E equals to MC triangle T
Not triangle, delta. What is it?
delta.
Delta. Now we call that this actually right here, this triangle is a Greek letter. It's a different language. And we call it delta. In physics, don't call it triangle. We call it delta. Now, okay, we have this delta T. Now, what is mass given? Tell me.
800 gram.
800 gram. So how do I convert, let's, okay, 800 gram, fine, into, do I know the specific heat capacity? I don't. And what is the change in temperature given?
12.
12. And how much energy is being supplied to the cylinder over here?
8,700.
8,700 joules. Fine. So we'll call this grams. This is the delta C degrees, and this will be joules. Now, if I have to solve this, I'll go from here and I'll say 800 joules divided by 800 grams into 12 degrees Celsius. The final answer will be what? Has anyone sent their answers? It's been 6 minutes.
Sir,
130.5.
130. Say that again.
0.5.
And okay, let me check the answer.
sir, that is
Yes,
E
sir.
is
Say that again.
E. What is E?
E is energy. Energy supplied. Thermal energy. So E is energy supplied. Energy being added or supplied to something. And what is the thermal energy here? Which is basically thermal energy. So whenever someone tells you that, okay, this much deliver is the same thing as supply. How much is basically giving, how much heat is being given. So thermal energy is 8,700. So we just write it over here. Is that clear? समझ आया? Okay, let me check the answer, which is okay, try one more time. Try one more time. Diana. This is wrong. I'll show you on the calculator. What all we're doing is 8,700 divided by 800 into 12. So what is the answer?
I'm getting this.
Diana, what is the answer? Same answer? Okay, let's look at the, but I am getting 0.906 on the calculator. So send me a picture of your calculator. What are you doing? Send me a picture.
Okay, sir.
Safa finished? Luna, you're silent. The time is going on. You'll not get so much time in the exam. Should I move on? Now, mic's on. Come on, both of you, quick. And tell me, how much progress have you made, Lola?
Calculating now.
Calculating. Safa,
جيب أصل ثانية.
Sir, I'm sending.
sending. Zahra,
On the calculator, we got 261 by 2.
261 by 2. Send me a picture. That's not what you're supposed to get. So send me a picture.
I was doing earlier with the phone, and now when I use the calculator, I got 261 by 2.
So tell me the decimal. Or the final answer. Press the decimal button over here. Because the answer is still wrong. So you'll have to send me a picture. Diana. Zahra, Safa, is that Safa or Zahra?
That's Safa.
Safa, your answer is correct. Good job. Rest of you, I'm waiting for an answer. Zahra, answer is correct. Good. And Lula, Diana, what is the problem happening in that question?
We sent the books we did.
Okay. Okay, there is an issue here, right? Now, which calculator do you have? Okay. Okay. Look at my calculator. Can you see on the board? I have the same calculator as you, right? Look at the board. Now, this is what you're doing. 870 divided by how much? 800 into 12. Is this the answer you're getting? Well, I can see, yes, you're getting the same answer. We'll bring it here. The problem here is that you guys have to put a decimal, a bracket here, or do it like this, 8700 divided by 800 into 12. Because what's happening is this and this is dividing, and all of this is being multiplied with 12, which is different. So try again by using this sign over here, this one. All right, understood? Try again. 8700, and then Diana, press 800 into 12. You'll get the answer.
Sir, I got 0.90625.
That's correct. So we have to see, these are some simple things which you need to be clear about. If you're dividing like this, then you must put a bracket here. And then again, you'll get the same answer as what you got right now, 0.90625. That's the answer. Thermal capacity, specific heat capacity is this much, 90625. But now they're asking us something about thermal capacity. How do I know the thermal capacity? Thermal capacity is this.
Is it the same formula you have given? Specific.
No, not the same formula. No.
And
Write in
that
your
one's
formula.
for what?
This is for thermal capacity, which
Yeah, but
is the
if it specific heat, which one is that?
this is the specific heat capacity. E equals density delta T. Specific heat capacity. Okay.
Okay.
But the thermal capacity is something else. So thermal capacity is equals to Q.
But sir,
Yes.
have been fusion and preparation too. Can you please go a bit up?
I'll go there in a second. Just a second. Now thermal capacity is Q over, let's say not this. Thermal capacity is M into C. That's thermal capacity. Write this as well. First write this. Write mass into specific heat. And the exact formula will be thermal capacity is equals to MC. M means mass, C means specific capacity. Quickly write this, tell me when you're done.
Then, sir.
Done. Now look at the other formulas. Let's take it from here. And here, okay. So the formulas are here. E equals MC delta T equals ML. And there's one more, which is thermal capacity is MC. That's it. Now you'll use the same formula over here. Zahra, any questions? Done?
Yeah, sir, I was asking about this formula, the one you have written here, fusion and evaporation. Oh, this is for latent heat. Okay, I get it.
Latent heat. Now, the final thing we're doing is finishing the question.
Can we solve a question on latent heat too?
In our next class, right? We'll do
Okay.
that. Just a second. Sorry. Let's continue. Now, the last question we're doing is this one. MC, mass into specific heat capacity, SHC. Let's call it specific heat capacity. Now, so you know the formula now. Can you find the answer? For this question, all I have to do is found it.
Yeah,
What is the answer?
725.
725. That's correct. What is the unit? Joule per
Joule.
degree Celsius. I'll give you the unit, not joules, joules per degree Celsius. I'll give you the units in a second. Now, all we have to do is E equals MC. And M I know is how much?
800.
Not E thermal, not E thermal capacity. So 800. And C was how much? 0.90625. So the answer is 725. 725. Fine. Any questions? Diana, Zahra, Safa. Now, since I'm here with you, you're not watching a recording, you can ask me. Otherwise, if you were watching a recording, everything will go over your head. You cannot ask anyone, right? So if I'm here, ask me, and feel free to ask me. Now, I'll just give you the units, but before that, just read this part quickly. Lula, read the question.
State and explain a method of improving the accuracy of the experiments.
Okay, write this down. As a question in your notebook, write method of improving accuracy of heat experiment. Fine, or let's say thermal. Let's just say heat experiment. Anything related to heat will be this question. Okay. Now the answer is going to be this. They want 2 marks. I'll give you 4. Choose any of those 4. First thing is insulate cylinder using lagging. Okay, and the explanation to this is explanation is reduces heat loss. I think we have done this stuff already. Insulation, if you lag it with something, it's going to reduce the heat loss. I don't want heat to be lost. That will interfere with my experiment. Next thing you could do is higher. Well, this should be enough actually, but I'll still give it to you. But no, just memorize this. That's all you need to know. So there's 1 mark for this, the reason, and 1 mark for the explanation over here. State and explain. Whenever they say state and explain, you have to say what something and you have to give explanation. Write this, tell me when you're done.
Thanks.
Done, sir.
Zahra, Diana.
Done.
Now, last thing we're doing is looking at the units of all of these. The units of, write it over here. After specific heat capacity definition, right after this, just write over here, unit. Unit is always joule per gram degree Celsius or joule per kg degree Celsius. It depends on what you're given in the question. If you have grams in the question, you'll put grams. If you have kilograms, you'll put kilograms. Now, what is the unit for this? Latent heat. That's going to be joules, and this is also going to be joules. Both of these are joules. Right over here, joules. Any questions? Now, finally, put an arrow like this over thermal capacity and write the units. The unit is joule per degree Celsius. Always. It doesn't never changes. But you need to know what the units are. Latent heat is energy, so it's always going to be joules. Thermal capacity is either joule per gram per degree Celsius or joule per kilogram per degree Celsius. And thermal capacity is always joule per degree Celsius. Any questions?
No, sir.
All right. So I think that's going to be all today, but I just want you to write one last thing. In your notebook, not much, just one last thing. Now you don't have to understand this, but or we'll do this in next class. Fine, that's it later. So that's all for today. Now, quick, Diana, can you recap what did we learn today, or what did we do? Diana, recap.
We took transfer of heat and radiation, reflection, and specific heat capacity.
That's it. Now in the next class, write in your notebook. We're looking at boiling, or let's just say latent heat. Latent heat, you can remind me in the next class. Latent heat and evaporation. Then the chapter will be over finally. Now I can't go faster than this. I hope you learned something in this class. You understand a few things. Practice more and more, you'll get more marks. Because see, I'm not hoping for you to get a B or an A. That's not my goal at all. What I want is for all of you to get A star. Is that clear?
Yes, sir.
All right. Now, because you can do it, don't think you can't. You can.